Okay, so hello everyone, very good evening guys, very good evening to all of you over here. So welcome to the live session only onto the YouTube channel Unacademy Computer Science. So how are you all doing? Just let me know in the chat box. I don't think I have put up the mic. Just a minute. Yeah, so hi everyone, very good evening everyone, very good evening everyone. Everyone, welcome to this live stream only on the YouTube channel Unacademy Computer Science. So how are you all doing? Just let me know in the chat box guys that how are you all and how are you all doing as well. Till the time, just let me open in your chat and it's read in your chats. Just allow me a minute, okay? So till the time whoever has joined in live stream, drop me a hi or drop me a yes in the chat box everyone. And let me know you are here. Okay, fine. Yeah, Aditya, I'm here. Okay, very good evening, Harshit. Very good evening. Hi, Shiva. Hi, welcome to live stream. Okay, great to that, Harshit. Fine. Hey, Vikram. Hi, Shreyas. Very good evening, Vikram. Hi, everyone. Very good evening to all of you present up over here. Welcome to the session, guys. So great to have you all who are over here in the live stream. Okay. So let's do one thing. Let's start our stream for today, right? So you're going to save to 60% off with your 6 months of free extensions onto GATE and ESE, CS and IT subscriptions. Okay. So what you could do, you can join the Prarambh and the Vishwas batches for your GATE and PSUs 25 and 26, which is going to start on 16th of December. Okay. So for your plus and for the iconic batches, the durations which are there is 12 plus 6 free months, 12 plus 5, sorry, 15 plus 6 free months, and 24 plus 6 free months. Okay. So whether you enroll for 12 months or 15 months or 24 months, you get a 6 months of free extension for the same. Okay. So you can save up to 60% off with all of these extensions over your GATE and ESCs. But that is only and only valid up till 16th of December. Okay, till 16th of December, this is going to go ahead. So enroll it as soon as possible, everyone. You can just go using my code, which is SHA10. Okay, and with that you can further go ahead and take out these courses for the same, right? That is what is over here. So you can save to 60% off with the 6 months of free extension onto GATE, CS and IIT subscriptions. What benefits do you get? You get the plus benefits for the plus and the iconic, both high quality printed notes. You do not get it in the plus, but you get them in the iconic. One-on-one live mentorship, do not get it in the plus, but you get that in the iconic. And customized doubt solving, you do not get that in the plus, but you get it in the iconic. Okay. So these are all the benefits which are mentioned up, that what do you get in the plus and what do you get in the iconic. Okay, so as told by me that this offer is only and only valid till 16th of December. So you can just use up the code SHA10 and you can just work with that particular over here. Okay, so that's about the things. So further you have this Prarambh batch, okay, which is for the GATE and PSU 25 for the CS and IT. Okay, it is going to start on 16th of December. The language is going to be Hindi plus English. It's going to be for the CS students, and the branch is going to be batch A, sorry. Okay, so you'll be starting on with the C programming and data structures and followed by the computer networks. That is what you will be starting on with. So just has to enroll into these batches using my code, which is SHA10, and you will very be soon able to like enroll into the courses and further take the courses from 16th of December. Talking about the Vishwas batch, so that is again GATE for the GATE and PSU 2026 for the CS and IT students. So it is going to start on December of 16th. Language will be Hindi plus English for the CS, and the batch is going to be batch A. Okay. So you'll be starting with the C programming and the data structures, and you'll be starting with the computer networks. That is all what you'll be starting up over here with, right? So the people who will be taking up the iconic subscriptions, okay, the people who will be taking up the iconic subscriptions, those people will get a list of books, that is like these all the books delivered their home within 15 days. Okay, so I told you about the 2 subscriptions, right? Plus and iconic. So in case you're going to take the iconic subscriptions, you'll be having these books delivered at your home within just 15 days. Okay, The books will constitute your digital logics, compiler design, operating system, programming and data structures, theory of computation, computer network, DBMS, computer organization and architecture, discrete mathematics, algorithm, engineering mathematics, and aptitude. Okay, so for all these topics, you will be getting the books delivered at your home within 15 days. So nothing can stop you from choosing your GATE, CS and IT dream. So you just have to get started with a no cost EMI and 0% interest on the loan for as low as rupees 3,599 per month. So in case you cannot take the complete course in one go, it's not a worry. Okay, in that case you can just take this EMI option where you get the 0% interest onto the loan also, right? And you can just like take that and go ahead with the same. So the process is very simple. You get the approval in 2 hours, the minimal paperwork, and the flexible 10 hours also. Okay, so terms and conditions are applied which are available onto the platform. So you can just call on to 8585858585 for all the details. So for all India mock test for GATE 2024, there is a series which is going on where you can just get an experience, get an exam kind of experience for the GATE 2024. Okay, so it is on the 17th and 24th of December. Okay, so if you just want to clearly get that how will your GATE 2024 exam look like, if you just want to have an experience for the same, or maybe solve it in the duration of the time duration, so you can visit this particular all India mock test for GATE 2024. Okay, so the process to enroll is that you have this QR code mentioned over the screen. You can just enroll into this QR code, sorry, just scan this out and you will be getting a link to enroll for the same. Okay, so for CS and IT and EE, the timings for the exams are 9:30 to 12:30, and for ECE, CE, ME and CH, the timing is 2:30 to 5:30. Okay, so the ranks are distributed in terms of 1 to 10 you get the 100% scholarship, 11 to 6 you get the 75% scholarship, 61 to 200 you get the 50%, 101 to 500 you get a 25% scholarship. So from the people who will be scoring rank from 1 up to 500, they will be getting a scholarship up from 100 to 25%. Okay, and these are all the Unacademy learners who have already cracked it. So congratulations to all of them, and sure you are going to be the one very soon. Great everyone. So I hope this thing is pretty clear to you everyone about like if you just want to have experience for the GATE exam, you can just like go on to this particular the QR which I had showed you, right? And you can, from there you can just enroll and further go ahead with the same. Okay, okay, fine. So what I'll be doing, I'll be starting on with the machine learning for today. Okay, as our topic will go for the machine learning. Before that, everyone just help me out with one question that whatever we studied yesterday, do you people have any questions for the same? Any questions from yesterday's class? Everyone just help me out with this particular answer. Okay, so let's proceed in for today, and today we'll be discussing in detail about your linear and logistic regressions. Okay, today we'll be seeing up in detail that what is linear regression, okay, what is logistic regression, right, and what do you do with the linear and the logistic regressions. Okay, let's understand about those for today's class. So let's start on with the linear regression first of all. So linear regression, what it is a kind of a statistical regression method which is used for your predictive analysis. So predictive analysis is something where you have to predict the output. Predictive analysis is something where you have to predict the output. So again, one more thing, linear and logistic, both the regressions come under the supervised learning. Okay, So linear regression, logistic regression, these are the part of the regression, and regression lies under the supervised machine learning technique. Okay. Okay, fine, Harshit, fine. Right, so I was talking about the linear regression. So that is a statistical regression method which is completely used for your predictive analysis. So in case whenever you have to predict something, okay, whenever it goes about predicting anything, that is where you use up this linear regression. Okay, so what is it? It is one of the very simple and the easy algorithms which works on the regression, and they show the relationship between the continuous variables. Okay, so it very completely works over the regression and even shows you the relationship between the continuous variables. That is what linear regression exactly is. So understand this is one thing. Whenever you come across any kind of a data or any kind of a problem where you have to predict something, okay, there you go on with the linear regression. That is what linear regression will help you, and that is where it will exactly help you out. So we will discuss about this in detail. So in case we are having only one input variable, you all know that what is it, right? So whenever you are having one single input variable, so in that particular case you will be saying that linear regression is called as simple linear regression. Okay, so whenever one input variable, that is termed as a simple linear regression. And if there is more than one input variable, in that case you will be saying that you are having multiple linear regression. Okay, so see, first of all, listen to me. These things are quite important for you to understand about that what is simple linear regression, what is multiple linear regression, and the reason is because in the case of these linear regressions kind of a thing, there is like if you are having one input variable, so you will be saying it is a simple linear regression. But in case you are having more than one input variable, then that is called as a multiple linear regression, right? So that is what you are having up over here in terms of your linear regression. Okay, so mathematical equation we go here is y is equal to ax plus b. Okay, y is equal to ax plus b. So y is actually your dependent variable and x is your independent variable, and a and b, you say these are the coefficients. Okay, or you can say constants, whatever you say. So yeah, I hope everyone remembers about the dependent and independent variables. If yes, then let me know that what do you mean by dependent and what do you mean by independent variable. Just help me out with this particular thing. Tell me, what do you mean by dependent variables and what do you mean by independent variables? We have discussed about dependent, independent in the most detailed way, right? Many times we even have discussed. So just help me out with these questions about the same. I am waiting for your responses, everyone. Right, absolutely right, Harshit. This is a basic maths equation. Y is equal to ax plus b, true. Because linear regression is something where you obtain up a straight line. Right, see here it goes and it completely works onto the straight line things. And whenever it comes about something about line, we have this equation which is y is equal to ax plus b, right? So yeah, that is the thing. Yes, everyone help me out with what do you understand by dependent, what do you understand by independent variables. I'm waiting for your responses, guys. Okay, Harshit, independent variable आपका part और independent codomain या range. Okay, ठीक है, fine. Okay, yeah, right. Harshit, see, you're absolutely right. You told about this particular domain and the codomain thing, right? Fine, that is absolutely right. Right. What about the rest, everyone? Okay, right. So see, y is equal to ax plus b. Now see, you already told me in terms of mathematical, in terms of this equation, that what is x and what is y. Right. Now, even I had told you about the dependent and independent variables, some other definition also. If you remember, everyone. So we discussed about this dependent and independent variables over here. Right. So this will also be like affecting, and this will also be taken care of once you are dealing up with the variables, right? Once you are working over the same, this dependent and the independent, both of the variables will be helping you out for the same, and that is what it exactly is over here. Fine. Right. So dependent variables are the main factor in the regression analysis which you use to predict and understand. That is called the dependent variables. And talking about the independent variable, the factor which affects of the dependent variables, or maybe which are used to predict the values of the dependent variables, those are called as the independent variables. And I hope everyone remembers about this dependent and independent thing which I am talking about, right? Yeah. So this is what linear regression is, right? Like I told you about what linear regression is, what is simple linear regression, and what even is multiple linear regression. And even we had seen about the mathematical equation, that is y is equal to ax plus b, where y is a dependent variable and x is your independent variable, and ab stands for your coefficients. So everyone, am I clear with this linear regression to all of you? The mathematical equation, and what do you mean by simple and multiple linear regressions? Are we clear with the same, everyone? Yes, everyone, tell me, are you all clear with the same, guys? Okay, Harshit, but one dependent variable can be independent if the function is explicit. Yeah, see, right, Harshit, that's absolutely right. Now, see here, I haven't given up any maybe the cases or the conditions as of now because those are not required. But yeah, you are absolutely right in this case of y is equal to ax plus b. You can really say that if one dependent variable can be independent, so in that case, a function can be explicit. That is absolutely right what you could say over here. Okay, like y is equal to mx plus c is independent but can be dependent if x is equal to y minus c by m. Right. Like y is equal to mx plus c, where x is independent but right, absolutely right, right. Fine, Arshit. Correct. Okay. Even we are having up a few applications too for this linear regressions. Application proceeds in kind of analyzing the trends and the sales estimates. Okay, analyzing the trend and sale estimates, salary forecasting. Okay, you have the salary forecasting also, and real estate predictions. When it comes about predicting the real estate or maybe the prices, whatever you say, right? So that is real estate predictions and arriving at ETAs in traffic. Absolutely right. So nothing we can absolutely call independent. Yeah, absolutely right, Harshit. Absolutely, you can call as independent or independent variables. Yeah, absolutely, you can do. Okay. Fine. Perfect. So I was talking about the applications for linear logistic linear regressions over here. So see, the very first application is all about analyzing the trends and the sale estimates. So you have to analyze what are the trends right now going on, right? And even you have to analyze up the sales as well which are into the market, right? That estimates you can very easily be do with the linear regressions. Okay. Next is about your salary forecasting. So yeah, salary forecasting is also something which you can do very easily. You just have to get in a lot of info about and maybe the date on which the salary and everything, like you can work with the same. Real estate predictions, the prices and the predictions of the houses, the properties, the real estate. So that is what it comes. Arriving at ETAs in traffic. So it is all about the traffic thing, like when the signal stops, when it goes green, when it goes red. It's all about that respective things, right? So yeah, these are the applications of your linear regression. Am I clear with that, everyone? Yes, everyone, are you clear with that? What are the applications? Okay, Harshit. What about the rest, everyone? Okay. Just a minute. Now, if you are clear with the same, we'll be moving ahead with the logistic regression a little bit, okay? Okay, just let me refresh this once. Perfect. Let's proceed in with the logistic regression now. Okay. So when you talk about another supervised learning technique, okay, when you talk about another supervised learning algorithm, so which is in use for solving up the classification of problems. So whenever you are having up any classification problem, there you will be saying that you can use up the logistic regression for this particular problem to be solved in. So because classification problems are mostly solved by the help of the logistic regression only. Okay, the classification problems are mostly solved with the help of the logistic regression. Sorry. So as to solve the classification problems, you can just use up the this logistic regression technique, right? So what happens? So in the classification problems, what do you have? You just have the dependent variables in a binary or a discrete format, kind of 0 or 1. Okay, and it works very well with the categorical variables like your 0 or 1, maybe yes or no, a true or false. This is what all it works well with. So in the classification problems, you have this dependent variables in a binary or the discrete format, kind of a 0 or 1. And it works very well with the categorical variable, kind of a 0 or 1, maybe yes or no, or true or false, or maybe whatever. Right? So this is what logistic regression is. So maybe understand every time कि whenever you have any classification problem, whenever you are having up any classification problem, you work well with the logistic regressions. Okay. So here you go in detail with logistic regression. So what it is actually a predictive analysis algorithm which works on the concept of the probability. It is a predictive analysis algorithm that works on the concept of your probability. Okay. So see, it is kind of that particular algorithm. Logistic regression, what does it use for? See, there as in we had that previously into the Linear regressions, we have that y is equal to ax plus b. That straight line thing, right? Okay, Harshit, but when we have to classify as prediction both, then okay, Harshit, I'm not able to read your complete message, and the reason is because that hurt symbol which is downside, that comes in between, not able to check out what exactly you have written. Okay, just let me complete till the time, and after that I'll just take in your question. Okay, just till the time, let me complete it once quickly. So see, understand logistic regression. It uses the sigmoid functions or your logistic functions, which is a complex cost function. So sigmoid functions which you're having, or the logistic functions which like over here, that is a complex cost function. Okay, so what happens is sigmoid function is used to model our data in logistic regression. So whatever the sigmoid function you are having, that is used to model up the data into your logistic regression. That is how this logistic regression exactly works. Okay, modeling the data in the logistic regression. So the formula here which you go ahead with is fx is equal to 1 upon 1 plus e to the power minus x. That is the formula which you are having. Fx is equal to 1 by 1 plus e to the power minus x. Okay, fx stands for your output between the 0 and 1 value. X is equal to stands for input into the function, and e stands for the base of a neutral program, or maybe algorithm, whatever you say. Right. Now see, this is what fx, x and e are really referring to. Okay. So see, again, for logistic if I talk, or maybe for linear if I talk, there is both of the like the things is key. There you both have the functions. Okay. For one you are having a straight line, for other you don't have a straight line function which is working on. So for linear you had in your y is equal to x plus b, and that is so true. It suggests by the name also linear. So linear means which is something straight. Right. Now logistic. Logistic is where you have this particular formula fx is equal to 1 by 1 plus e to the power x. Harshit, but then we have to classify as as prediction both them. Okay. Harshit, not able to actually see your message. If you can once again type in your message over here, Harshit. Can you once again type in your message over here, Harshit? Just resend that. Okay, ma'am, but when we have to classify as well as prediction both, linear or logistic linear. Okay, when you have to classify. See, when you are when you have the data, when you are done with your analysis of the data, after that only you can very simply or very easily try to classify whether it is what kind of a data, what kind it is solving. It is solving up your linear regression or it is a logistic regression. Once you have the data, once you have the analyzed up your data, after that very easily you can just simply go ahead and work on the same. Either you can say it is a linear regression or you can say it is a logistic regression. Okay. Right. Fine. So yeah, this is what we have in the logistic regression. It is a predictive analysis algorithm which works under the concept of probability, and it uses up your sigmoid function or maybe the logistic functions, which is a complex cost function. Okay, which is a complex cost function, and this sigmoid function is used to model up the data in the logistic regression. Okay, this is completely used in for modeling up your data in the logistic regression. That is what it is exactly helping you out for the same. Okay, perfect. Now let's move ahead and let's see out what are the applications for logistic regression. So applications for logistic regression are medicine. Okay, it goes very well with the medicine, gaming, okay, text editing, and your hotel booking. These are the applications of your logistic regression. Okay, these are the applications which are there for your logistic regression, right? So everyone, are you clear with the same? Okay, fine, Harshit. Fine. Okay, pretty good. Cool, fine, everyone. Okay, now see, like this is what you exactly mean by a logistic and a linear regression. Okay, this is what exactly you refer as your linear regression and as your logistic regressions also. You are very well known with the applications, and what are the applications for linear regression, what are the applications for logistic regression. Harshit, how logistic regression achieve these applications? Okay, see, Harshit, medicine, gaming, this is all about, see, medicine is something where you have to classify, right, whether that person is having that disease or not, right, that you have to do in the medicine. So first of all, it is a classification problem. So that's where logistic regression will be going in the case, right? Now, see, logistic regression and these all the like algorithms, whatever you are having, these are just kind of a, you can say, reference kind of a thing, right? You use of this algorithm, it's just that you are using that algorithm, building about that particular one, building your own model. That is what you are exactly doing onto your own. These particular, like these logistic linear, these all the things you use up over here, and these are just for your sake of helping you out in the case, right? These let you know about the algorithms and a few functions from these algorithms you can use exactly, right? But it comes about ki when you are having up these algorithms with you, exactly how you'll be working with those, you'll be preparing your own model and everything. That is all what you would just do with the logistic regressions. Sorry, with your own model building about the same. That is what happens up over here. Okay. हर्षित, बेसिकली फिल्टर लगाने में यूज कर सकते हैं ई कॉमर्स में. या एब्सोल्युटली हर्षित, yes you can do. Whenever you have to apply up the filters, okay, onto your e-commerce sites also, you can absolutely use this particular thing over there. Okay, not an issue. Right, perfectly you can use it over there. So clear with that, everyone? Clear with that, everyone? Okay. Now see, you have learned about a lot of things, right? You have learned about classification, you learned about the linear regressions, logistic regressions, you learned about your support vector machines, KNN, right? Then you learned about your naive based classifier, right? And you learned about your decision trees, bias variance trade-offs. So you have learned a lot of things as of now under in terms of the like algorithms in machine learning or things like that, right? So now my question to you people is ki according to you, you let me know ki like according to you, which is a kind of a algorithm which is a savior kind of algorithm. favorite kind of an algorithm means ki is like, according to you, do you think is there any algorithm which you can use in any kind of a data? Is any algorithm kind like that do we have in the list? Help me out with the answer for the same, everyone. According to you, do you think is there any kind of any algorithm which can be used in almost all the cases of a data? Or all the algorithms have their different sets mentioned up? Or maybe all the algorithms have their key in this kind of data, this is how the algorithm will work. In that kind of a data, this is other algorithm that will be working, and accordingly, right? Okay, Harshit, decision trees. Yeah, right. Absolutely right, Harshit. Decision trees are something now which can be worked over, which can surely be like seen in terms of having up your algorithm in a decision tree. See, because decision tree is something which helps you to get in the idea of your data very clearly. Right? It helps you to get in the idea about your data. Ki, like how is it further classified? It helps you to make up the further branches. You have the root nodes, you have the leaf nodes. So it helps you to better understand up your data. Right? So yeah, decision tree is something which you can be using. But see, again, Harshit, my question was, is there any kind of algorithm which you can use in almost everyone? So see, decision trees, yeah, you can use it, right? But in terms of decision trees are said that those are better to be used under the classification part. Right? It is better that you use of the decision trees for the classification. Right? Not for the regression, right? But as an example, you can take that particular one. Except one case, you replace that by random forest. Yeah, random forest is something like very different. Absolutely. True. Fine. Absolutely right, Harshit. So yeah, this is something what you have up over here. Now see, further talking about a few more things in terms of the algorithms which we have studied till now, because like we are almost about to finish up with your supervised learning. Maybe tomorrow we'll be having up a few more topics for the same. But okay, let me know what will you be choosing. You'll be choosing SVM or you'll be choosing KNN. Support vector machines versus K nearest neighbors. Maybe what is the difference between those? Let me know first of all that particular thing. Difference between the support vector machines and the K nearest neighbors. According to you, what is the difference between them? And according to you, what should be the preferable? Harshit, SVMs are preferable. Okay, fine. SVM are preferable, but can I know the reason as well why, Harshit, you will be saying that SVMs are preferable? Maybe what is the reason? Okay, I accept, Harshit. Like I even want everyone else as well over here to respond me, guys. Please respond me out, because it will be better for me to understand whatever you people are trying to say. So just try responding me, guys, very soon. No need for calculation of, yeah, absolutely right, Harshit. That's absolutely right. The answer which I was expecting. So yeah, see, SVM and KNN. K nearest neighbor is good. It is kind of an easy algorithm, a simple algorithm, easy to apply kind of algorithm, right? But what comes under KNN is key, first of all, your value for the, there is no particular method for finding that value for the K, right? It's just that you have to take the assumption for that. Like whatever the most preferable value is 5, and except that you have to take the other kind of the preferences only. right? There is no such method for finding the value of k. And second is ki under your k and n you have to find the Euclidean distance for your particular question or whatever the graphs, whatever you are having, right? Now finding up Euclidean distance, this increases the computational power, so it obviously is not a good thing. It will take a long time to get executed, right? Right, and it is kind of a preferred even for your complex data sets. Absolutely right, is preferred for your complex data sets, and again the reason is that same only, right? So in that case, SVMs are a better alternatives, okay, in terms of your working up with the things, in terms of you getting the idea about the same, in terms of not finding the Euclidean distance. Computational power is also not weak, okay. So in that respective case, we very easily say that okay, SVMs are better than KNN, because there is no such thing about finding the value of k also, or anything like that, right? No linearity case, absolutely right. Right. So yeah, so if we compare about the KNN and we compare about the SVMs, so it's better ki when you have to work on small data, then you can take the KNNs, right? But whenever it comes about working with a complex data, large data set, big data, so there you can very surely go ahead with the SVMs, a support vector machine. Okay, fine. Okay, decision trees, you know, these are betterly used whenever you are having something in terms of displaying in terms of graphical representation, and accordingly then you have to work over the same. So yeah, that is where it actually helps you out. That is your decision trees. These really help you out with the same thing. Are also handled good. Yeah, right. Absolutely right, Harshit. These are also handled good. Fine. Perfect. So this is what you have under this decision trees, KNN and SVM. Now talking about the bias variance trade-off. Right, so everyone let me know what do you think about bias variance trade-off. First of all, what is bias variance trade-off, everyone? Let me know about that thing. Because yesterday due to internet issue, the class ended in between only. It got stuck in between only. So tell me everyone, according to you, what do you mean by, or maybe what is bias variance trade-off? Middle condition between low bias, high variance, and high bias and low variance conditions. Absolutely right, Harshit. This bias variance trade-off. This is something where you have a middle condition between the low bias and high variance, and high bias and low variance. I just take you towards that one only. See, what do you mean by exactly the bias? So bias is exactly the difference between the prediction of the values by the machine learning model and the correct value. Okay, so whatever is the difference between the prediction of the value and the correct value, that is what your biases mean. Bias actually means out, right? Now, being high in biasing, what it gives you a large error. It gives you a large error in the training as well as in the testing data set. Okay, so it is recommended that any algorithm, it should always be low bias to avoid the problem of underfitting. Fine, and high bias, the data predicted is in the straight line format, so it doesn't fit out accurately into the data of your data set. Yes, you have the problem of underfitting also over here. So if this algorithm is like in the case of your the fit of the algorithm, right? If the fit is too simple, then in that case you say it is a high bias and low variance condition. So in that case it is error prone. And if it fits out too complex, right, then in that you will be saying it is a high variance and low bias. So in the later condition, there will be a new entries that will be performing well. Fine. So there is something kind of a both of these conditions which is known as a trade-off or your bias variance trade-off. So yeah, these things you are having up over here in terms of trade-offs or the bias variance trade-off, which is completely mentioned up over here for the same. So right, this is what bias variance trade-off. This is simply a condition between the high bias and low variance, and low bias and high variance. So yeah, everyone clear with this bias variance trade-off also, guys? See, bias variance trade-off, this bias, this variance, these things, this is kind of an algorithm which is used on with a where you are having up a numerical data, and it works well whenever you are having that statistics and probability things, whenever you will be applying. With that, this particular algorithm will work better because you have to find the variance, you have to work with that all conditions. Okay, so yeah, that is what just comes under your bias variance trade-off. Okay, fine, Harshit, fine. Okay, we are clear with the bias variance trade-off. We are done with your linear logistic regressions and everything for today. Okay. Okay, so let me know, guys, do you people have any questions which you want to ask me out? Okay, Harshit, once we'll be discussing about the ridge regression afterwards. Okay, I guess the class is I already scheduled up your classes till 20th of December. So I guess tomorrow, maybe day after tomorrow, you already have this particular topic with you. That is ridge regression. You have this thing with you. Okay. Okay, hi Kiran Kumar. Hi, welcome to the class. Vaibhav, man, or ML course is sufficient. See, Vaibhav, here in the class now, whatever we are learning, so in that respective case, I would say ki in terms whatever we are learning up and the things, that is, I'll be covering up all the topics for you all, right? And when it comes about practice questions, solving up the questions, doing up the practice, so we will be doing that as well very soon. Okay, once I give you a clear idea about the unsupervised learning also, maybe next 2 to 4 days, then we'll be very coming up with your kind of the MCQs, kind of the questions also, right? We'll be coming on with all of those things over the same. Fine. So yeah, that is where I would say it is sufficient, but it's said to you all that do attend regularly. Try to make sure that you are answering out over here in the class, right? These things you have to take care once you are like going with the things. Okay. Okay, Kiran, talking about your application, the practice sessions, we will be starting in next 3 to 4 days. Okay, we'll be starting up your applications and the practice sessions in next 3 to 4 days actually. Okay, so just give me 3 to 4 days and we'll be going ahead with the application of the stuffs and everything for the same. Okay, fine, Vaibhav. So what I'll do, let's go in the very starting for your where we started on with the supervised and the things. Let's take a quick revision of all these terminologies which we have discussed up. Most welcome, Vaibhav. So let's understand once again about these terminologies. So starting with the dependent variables. So the main factor in regression analysis, can we have a record session on YouTube, ma'am? Yeah, Kiran Kumar, you can just visit onto the playlist section and they will be getting a playlist where you are having up the complete all the classes, everything will be saved into that particular playlist only. Okay, whatever the sessions I have taken till now, those all you will get under that same playlist. I guess that would be complete GATE 2024 kind of a name or something. Just search it out once. Okay, you can check that under playlist section only. So yeah, talking about the dependent variables. So the main factor in the regression analysis is that when you want to predict or you have to understand, right, which you have to predict or you have to understand about that particular factor or variable, that is termed as dependent variables. And dependent variables are also known as your target variables. Okay, most welcome Kiran. So your dependent variables are also known as your target variables only. Okay, talking about the independent variable, the factors which affect up your dependent variables or which are used to predict the values of the dependent variables, those are called as your independent variables. So you say that these are the predictor. Okay, you call them as a predictor. Talking about your outliers, so see, outliers are kind of an unwanted data that you have up, right? You just have to work with that unwanted data. It can be either very low or you can have very high value in comparison to the other observed values. That is what you have in the terms of the outliers. Okay. If we talk about the multicollinearity, so see what happens in multicollinearity. So if you are having up the independent variables and those all are highly correlated with each other. Okay, if the independent variables are highly correlated with each other than other variables, so in that condition it is called as multicollinearity. Okay, in that condition it is called as multicollinearity. So it should not be present in a data set because it creates a problem while ranking up the most effective. Absolutely right. So there should not be any condition of multicollinearity in your data because that particular thing affects out your variable a lot. Right? While ranking you get affected with the multicollinearity factor a lot. So always make sure that once you have applied your algorithm, once you are dealing with all those things, the model and the training, everything. So just try checking it once and seeing it once that your data should not contain the multicollinearity. Okay, just have a look over that every time you are going with these things. Then you are having the underfitting and the overfitting. Fine. So if your algorithm works well with the training data set but not with the testing data set, so in that case that particular problem is called as your overfitting. Okay. So if your algorithm does not perform well even with the training data set and with the test data set also, then it is underfitting. So guys, it is always recommended that whenever you are working up with the data, whenever you are working with the data, you have to be very you have to see about these conditions, whether these conditions are not occurring, this like kind of multicollinearity condition, your underfitting and overfitting conditions. You just have to check that these conditions are not occurring into your data. Fine. So this is what you have up over here for the multicollinearity, underfitting, overfitting. And always make sure that once you are seeing up once you are having the data in your hand and you have been asked at what you have to do, try checking all the things. First of all, try to rectify whether it is whether it is supervised, unsupervised, what kind of a machine learning technique it is. Then see under that what algorithm of supervised learning or what unsupervised algorithm can be taken care of. Right? This is exactly the process which you have to follow while you are doing up the things, while you are working up with your data every time. Okay. So make sure you are just checking this out. Make sure you are satisfying out this multicollinearity, underfitting, overfitting, all of these conditions into your analysis. Hi Gate Q. Hi. Right. And yeah, one more important thing guys. Tomorrow the session will be at 6 p.m. in the evening. Okay. So tomorrow's session is at 6 p.m. guys. So make sure everyone you will be joining 1 hour early tomorrow. That is at 6 p.m. Okay. Because I'm traveling up somewhere. So just because of that, we are having up the class tomorrow at 6 p.m. and for the next 2 days, that is 16th and the 17th. It means your Saturday and Sunday. We will be having the class early in the morning at 9 p.m. Okay. Tomorrow, that is 15th, class will be at 6 p.m. in the evening. And on 16th and 17th, that is your Saturday and Sunday, the classes will be at 9 a.m. in the morning. So do join for 2 days and then from 18th we'll be having in the same time as 7 p.m. we used to have. But just because I'm traveling somewhere because of some other things as well, I have just shifted up the timings. I just don't want to miss any class of yours. So just the thing, I have shifted the timings a little bit. Okay, the classes have already been scheduled. You can check those onto the channel. You will be notified about those. And do press that notification button, notify me button, so that in case you forget the new timing, you will be known about this thing. Okay. Great guys, great, fine everyone. So do you people have any questions or not? So guys, in case you people do not have the questions, we can end it the class for today, because this is what I had in for you all for today's class. Okay, fine, Harshit, fine. So if no questions, in that case, thank you everyone for attending up the class. Thank you guys for being here. It was great having you all. I'll see you all tomorrow at 6 p.m. in the evening, 1 hour earlier. Okay, just remember the timing. Don't forget to join at 6 p.m. tomorrow. Okay, so thank you everyone for joining in the class. Thank you everyone for being here. I'll see you all tomorrow at 6 p.m. in the evening with the further new topics for you all. Till the time, thank you everyone, and take care. Have a great evening and a great night ahead everyone. Thank you guys. Bye bye. Take care.